Hello, everyone. I'm here to talk about an application we've been developing over the past months at IRCAM. We named it Koryphai, and I can describe it as a composition environment for distributed music systems. So I start with giving a little bit of context. So what we're interested in are situations in which sound-making devices are connected to a local network and are used as an array of speakers for musical composition. And in this case, we ignored questions of interactivity only to consider the devices as a sound projection tool. One example of such system is the piece Color Fields by one of our co-author, Luciano Barbosa. He composed it at IRCAM in 2018. It's a piece for accordion, electronics, and smartphones. And at the time, the technical framework for smartphones was developed specifically for the piece. But despite being successful, it had some limitations that made the composition process a bit tedious and difficult to test and change. For example, you had to manually write down the synthesis data for the smartphone into JSON file. So we decided to develop Koryphai with the intent to solve these limitations. And our work was guided by two main objectives. The first one was to leverage existing users and composers' skills. To do this, we built Koryphai on top of two existing tools. The first one is Bach, which is a Max MSP family of package for computer-assisted composition that is widely used by composers. And the second one is Soundworks, a framework for developing distributed multimedia systems that has been in development at IRCAM for a few years. And Koryphai actually is built as a sort of bridge between these two tools. And the goal of Koryphai was to translate the language of Bach into the language of the network of devices. The second objective was to create a solution that is flexible, modular, and open. And to do this, we followed the methodology of meta design, which recommends that the application must evolve within the hands of the users, who are seen as co-designers. And that's part of why we decided to work in close collaboration with composer Luciano Barbosa. To demonstrate this, here's a development timeline of Koryphai, with on the left the different steps in the development, and on the right the different tests and uses in live situation that we did with Luciano. So as we finished a first functional version of the application, we tested it in studio at IRCAM using examples provided by Luciano. And this allowed us to understand how an experienced composer would use the application, and he gave us a lot of insights and ideas for features that we could implement, and this allowed us to readjust the course of development. Then, when we had the first complete version of Koryphai, we had the opportunity to test it in a live condition at the Bobigny Conservatory, where Luciano created his piece Refraction for smartphone. And finally, we were recently able to fully recreate color fields within Koryphai at IRCAM. And Luciano testified that the composition process was much simpler and more practical, because now all the synthesis data is contained entirely in Max MSP. So it can be manipulated in a real time. I'll show you a short video of the session. So now I'm going to present Koryphai and some features. I start with a global overview. So Koryphai provides you with three things mainly. The first one is a set of MaxMSP objects that interact with the Bach library. Second thing is a web-based client for the audience's devices to play sound using the Web Audio API. And finally, a web-based interface to that provides control, monitoring, and customization of some aspects of the application. So the way it works, you can see on this diagram, is that you start by composing something using the Bach library in MaxMSP. And then the data from your composition is collected and formatted as a dictionary within Max using the Koryphai objects. And then this dictionary is sent to the server using the OSC protocol. And when the server receives a dictionary, it then dispatches the notes to the clients connected to the network, who then play sounds in the browser. So now I'm going to switch to MaxMSP to show you directly how it works. So here's a demo patch I did. You see that there is two main objects. The first one is this one. It's an object from Bach. It's called the bar.roll, and it's sort of an interactive score. So you can create notes, and to each note you can attach various data using slots. So the first slot here contains an envelope. And then when I press play here, playback is activated and data will come out from this outlet that contains all the data of the composition. And we collect this data using this object, which is a Koryphai object called Koryphai kp.to soundworks. And this object has two functions. The first one is to format the data as a dictionary. And the second one is to send the data to the server. But before I do that, I need to define the mapping between Bach and Koryphai, because for the moment, this has no idea which data to collect from the composition and to which parameters in Koryphai they must correspond to. To do this, I must send these messages that tell which parameters I want to collect. So for example, the sense information, velocity, the slot one information, and then to which parameters in Koryphai they must be mapped to. So I want the sense to be mapped to frequency, velocity to velocity, slot one to the amplitude envelope, for example. And now when I press play, you see that all the data is being collected as dictionaries. So now data is then sent to the server using a small object in Max that we developed. This one, it's called soundworks.sharedState. And the way it works is that it's attached to an internal state on the server that is synchronized with all the web clients and the MaxMSP patch at the same time. And so communication can go both ways between all these elements. So then I should be able to go to the web client, and it should now play sound. Nice. So the way it works is that once the web client receives the dictionary with all the data, it feeds it to an audio engine we developed using the Web Audio API. So I'm going to do a longer demo after that, but before that, I want to just present the controller interface we developed in the browser, from which you can control various things in the application. For example, audio buses. Let me play again. I can mute it or change volume in real time, and all sorts of stuff. I don't have time to show you. And also, what we included are possibilities to customize some aspects of the application. So you can, using these editors here, create your own synthesizer using the Web Audio API. And you can also create your own dispatch strategies. That is the set of instructions that the server will follow to dispatch the different nodes to the clients connected to the network. And to end this presentation, I want to try a demo. So you will need to follow these instructions. So sorry for remote viewers. This is only a local thing. And as you follow the instructions, I just want to say that Koryphai is available on GitHub at the following address here. And you can feel free to test it, send issues, and contribute to the wiki with your own components, for example, synthesizers. Sorry. Yeah. Sorry. So I see that some people are connected. Excuse me. Okay. So I will start the demo. I will press play. I need to unmute this before. You need to be on this Wi-Fi network. So sorry if you're not connected, I will start the demo now. So you should hear sound coming from your phone. What I can do is change the composition in real time. So I can delete these notes, for example. Or I can put them back. What I can do also is to change the dispatch strategy. So for the moment, all notes are sent to all the devices, but I can choose to change it so that notes are only sent to only one device, or spread it evenly through the room. And what I can do is also to do a little live coding. If I switch to my custom synthesizer here, I can change the sound. For example, the oscillator type. And I can add a second oscillator, an octave lower. And I can add an LFO to control the frequency of the first oscillator. You will hear it in a second. And so I can turn it down for a second. And last thing I want to show is that I can control this LFO directly from the bar.roll. So to do this, I must tell this object that I want to use a new slot. So I use a slot 3, for example, and that the data in slot 3 will control the LFO gain. And now I can use this slot here to control the LFO gain for this note. And this note. And that's it. Let me mute it. And thank you for listening. If you have questions, I might answer them.
Thank you very much. Are there questions for Aliénor? Sure there
are. In your original definition of the piece, you showed us an accordion player. So how does real-time input come from a performer, not just from the box score?
Sorry, can you repeat the question?
You show the illustration of an accordion player performing the piece, and what we just saw was auto-generated from a box score. So how does a live performer participate in the system?
In the example I showed, it was simply, there was no interaction between the accordion sound and what was coming out of the smartphone. It was just two compositions in parallel, but you can. I'm not that skilled with Bach, but maybe you can analyze the sound from the accordion to then compose something with it in real time.
Thanks for that awesome demo. Is there a limit to the length of the piece that you can compose in this window?
No, actually, the limit will, for the moment, it will be on the number of notes in a chord. If you send too much information at one time, it will break. But we intend to fix it at some point. And on the GitHub, we have example patches by Luciano. And there's one that analyzes sound and then resynthesize it. And when you analyze some sounds, you have huge clusters of chords, and it will break if you do that.
I noticed it said that it was a microtonal performance with the accordion player.
Yeah.
Is there a specific system you're using?
No, actually. So this guy here, Etienne, the performer, he developed his own accordion with a microtonal.
With a microtonal system?
Yeah, microtonal system built in it.
Okay, and does that feature into the electronics at all? I noticed you're outputting things in cent.
Yeah, well, that's Luciano, his composition style.
Okay.
It's based on microtonality and drones.
Okay.
So that has nothing to do with us, but we worked with him.
Thank you.
One more question?
Thank you very much for your presentation. And the first question is about the number of devices you can connect to the server. Have you tried a limitation without the desynchronization between the devices?
We haven't tried. Well, the most we've done was maybe 20, 30 phones at the same time.
Okay.
We haven't done any intensive tests.
Okay, and there is some kind of delay, or it was all synchronized perfectly?
You mean delay between the phones? So what we use is a plugin in Soundworks, and it synchronizes all the phones, and it's supposed to work up to 5 milliseconds.
Okay.
But I don't. You have to ask Benjamin, because he knows this stuff more than me.
Okay, thank you.
Yeah, thank you very much. You can talk to Benjamin for the technical details. I remember that we tested the Soundworks One system some years ago for 2,000 phone connections on a mini Mac. Thank you very much. Thanks. Let's thank once more, Aliénor.